I am Sheikh Amir Basha from class ECC. My regular roll number is 24BQ E6. I am now explaining about the topic logic gates. Logic gates are the fundamental building blocks in the digital electronics used to perform the logical operation based on the input provided to and give the logical operations can be either high or low 0 1. Logic gates finds their use on a one-day to one-day lives, such as the achievements are our telephones, laptops, and tablets and memory disks. By combination difference, logic gates complex operations are performed to the like flip-flop contents processors. Most of the logic gates are made to their basic several many types of the logic gates that are used from perform the logical operations in the digital systems. Those are AND, OR, NOR, NAND, XOR and XNOR. Now I am explaining about AND NOR gates. And AND NOR AND gates are used to perform logical multiplication of binary inputs. The output stands of the AND gates be height 1 if but both are input height 1, else the output stands will below 0. If any of the input low 0, then the below expression or logics of an AND gates is the logic multiple of the input denoted by a full stop or single dot. A into B is equal to X. The values of X will be truth when the both the inputs will be truth. Example: A is an input, B input to X is equal to A into B. 0 comma 0 into 0 0, 0 into 1 0, 1 into 0 0, 1 into 1 1. Then we can see the diagram clearly. Now we are going to OR gate. The most of widely used the digital circuits. The output states of OR gates will be get high 1 if any one of the input state is high or 1, else output of state will be low, either 0. The Boolean expression for OR gates are logical addition of denoted by the plus sign as x is equal to a plus b. The properties of NOR gate is and NOR gate have the following two properties. It has two or more inputs laid at a time. When all of the inputs or NOR gates are low or logic 0, then the output of it is low or logical 0. Now we can see the truth table. Input A and input B, then we can see output 0 plus 0 0, 0 plus 1 1, 1 plus 0 0, 1 1 1 plus 1 1. Now we are following to see the output of the diagram. The OR diagram is shown. Now we are next moving to the NOT gate. And digital electronics, the NOT gate is the one of the basic logic gates having only a single input and a single output. It is also known as inter or invisible. When it is the input signal is low, the output signal is high and vice versa. The wall expression of NOT gate is flows y is equal to a bar or a is equal to a hash. The value of y will be high when a will be low. The truth table of NOT gate is. Then we can see the diagram. Now we are moving to NOR gate. The NOR gate is a type of universal logic gates. It has two or more inputs and gives only one output. The output state of the NOR gate will be high as 1. When all the inputs are low, 0. NOR gate returns the complete result of the OR gate. It is basically combination of two basic logic gates, OR gate and NOT gate. The Boolean expression of NOR gate is flow. If A and B are considered as two inputs and O are output, the expression from two inputs or NOR gate will be O is equal to A plus B hash. The value of O will be truth when all inputs are set 0. Then we can see the truth table. Input A, input B, O is equal to A plus B slash. Then we clearly observe the truth table. Now we can see the NOR gate diagram. Next we are moving to NAND gate. The NAND gate is another type of universal gate. The NAND gates or NOT gates is the combination of two basic logic gates and NAND gates and the NAND gate connected in the service. It takes two or more inputs and gives the only one output. The output of the NAND gate will be gives the result high 1 when the either of the input is 1 or the both of the inputs are low 0. In simple, it performs the universal operations and NAND. Say we have two inputs A and B and the output X, then the expression is X is equal to A into B hash. Now we can see the truth table as we seen in the above information. Now we can see the diagram. XOR gate. The digital electronics, there is a logic named XOR gate which is used in the digital circuits to perform the model sums. It has the reference of executing OR gate or XOR gate. It is used to externally atomic logic circuit. The logic or error detected circuit. The XOR gate can be two inputs are dissimilar. If one of the two low and then the other one will be the high one. Say we have two inputs A and B and the output is called X, then the expression is one Boolean expression of X XOR gate is follows. X is equal to A slash B plus B slash A slash B. Now we can see the truth table clearly. We get the outputs. Now we can see the diagram. Now I am telling about XOR gate and the last topic. The XOR is an combination of XOR gate and NOT gate. The output of the XOR gate is high 1 when the both inputs high 1 and low. In the own words, the output NOR gate is high 1 when the input are the same. The XOR gate can be sometime be like equivalent gates if some words NOR gate will be completely of the XOR gate. The following Boolean expressions are XOR gates. X is equal to AB plus A slash B into A slash into B slash. Y is equal to X or slash Y is equal to A into B. Now we can see the inputs of the truth table and the diagrams. The summarizing logic gates totally. and thank you.